Hi, it's Mel. I'm at IBC 2025 on the Grass Valley booth, and we're going to hear from Vincent Trussart about the media exchange layer. So sit back and let's hear all about it from Vincent.
So MXL is a media sharing framework that is being worked on by multiple vendors under the EBU umbrella. It's an open source project covered by the Linux Foundation. We want to define a memory sharing mechanism across multiple containers. So I have a software-defined media function, an encoder, a decoder, a keyer, a switcher. They can all coexist together on the same environment. So across multiple containers, on-prem or in the cloud, and share memory, share video frames, share audio, share metadata as fast as possible, as efficiently as possible. So we want to leverage what the computers are good for. They're good at sharing data, big buffers, big offload using fabric technologies. Computers are really not good at 2110 small packets. They work hard at encoding, packetizing, depacketizing. So we want to create a framework where the data is available for different software-defined media functions running on the same execution environment. The success of the project will be an SDK, not a specification. So we want to have living code. We want to have production quality code that is implemented by vendors such as us or other vendors on the booth. So here we have a solution here showing a multi-viewer, combining video, software-defined media functions from different vendors, from AWS, Grass Valley, Matrox, Riddle, and TVU, all sharing the same MXL environment, all picking and choosing video frames from different vendors, contributing back, writing back in the MXL world, in the MXL domains.
And we must be saving both CPU, latency by not going back to the packetized environment.
It's tremendous the amount of CPU and latency we're saving. There's a vendor that is doing a latency demonstration. 2110 at 30 hertz is about 33 milliseconds latency. You have to wait for the end of the frame to have your full frame. RDMA between hosts was about 1 millisecond, and MXL on the same machine is 0 millisecond. It's instant. We're not talking about senders and receivers. We're not packetizing encoding. We're talking about readers and writers. So we're even saving memory copies. So you have access to the buffer in a secure way. So you can run in cloud or hypervisors very securely, but you're still able to access the memory buffers without even copying the data. It's there for your media functions.
And of course, this technology really doesn't care whether it's in the cloud or whether it's on premise. It's really just more about a compute environment and a method of transferring the content around whilst you're inside that one.
We want this to work for small environments such as a Raspberry Pi, an audio console, a big computer with containers, or a cloud hyperscaler. It won't cover cloud to ground and ground to cloud. It will cover local execution environments on the same machine or in the fast fabric. So if you have a fast switch, a 400 gig network, using RDMA accelerations, we'll be able to move the frames as fast as possible using RDMA technologies. So the network adapters are doing all the work. The OS is not even involved. So it's moving and saturating the pipe and sending the frames as fast as possible over the fat pipes that you may have in your network. So basically, where the broadcast industry is leveraging what the IT industry has been building over the last decade with the big data centers, the big AI-focused data centers, lots of RDMA, lots of acceleration. We're now leveraging this technology instead of building broadcast-specific technologies.
Fantastic. All right. Thanks so much, Vincent. That's really good.
Thank you so much.
Pleasure to hear from you about this awesome new initiative. All right. All the best.
Great stuff.